Hello and welcome to this video on the AQA A-Level Paper 1, Summer of 2026, skeleton code, and the skeleton code this year is AntSimulation. So I'm going to talk you through the program, okay, in this first video, and then in future videos I'm going to do hopefully some changes to this video that are a bit off the beaten path, not maybe what you've seen before in the AQA skeleton code wiki, which if you haven't seen yet, do check that out. There's some good examples on there, or if your teacher has been good enough to buy the zigzag package, there are some good examples in there, but they are of course copyrighted, so I'm not going to do those. However, not that I know what's going to be on the paper, of course. Anything that is already on the zigzag exercises is definitely not going to be on the paper. They might have something similar, but not the same. So I'll go through some changes to this program. So this is the code. This is the code that you'll see on the day. Just to go through a couple of things, I've put this through Copilot. So this comment, of course, is there courtesy of AQA. They've described what it is. Copilot has helpfully put in some extra comments for us to just for this particular exercise of talking you through the code. So of course you're not going to get these comments there when you are in the exam. You'll get just the basic code and nothing more. So that said, it's pretty self-explanatory once we've been through the program. So what I'm going to do first of all is I'm going to do the simulation. So this is a simulation. Of course, hopefully you've been through the program by now, but if not, it's not too late. Now is certainly the time to do it so that it's fresh in your mind for the exam. So I'll run the program. The program is an ant simulation. You basically get a board that comes up. So let's give this a go. So there's you have the option of entering 4 simulation numbers. Now, I've just noticed there, it doesn't actually tell you what your options are when the program runs. It just gives you a enter simulation number and that's it. So if I feel friendly and type in hello, that just simply crashes. So it gives nothing more than that. The reason it crashes, of course, is that these parameters have not been set up. We'll come to that again in a minute. So I'll stop the program, run it again. I know that we can enter, I think there's 4 or 5 different, I think there's 4 simulations. So I'll do simulation 1. Now, then you're given 4 options. Now, this doesn't have the same problem here because this is expecting a string, and so even if you enter a number or say hello, it will just display the option again. So we'll explain that in the code in a minute. Option 1 displays the overall details of the board. So this basically shows you a board. It's displayed not in a particularly good way. So one of the future coding examples may be that we will try and change this. So you can see that this is a 5x5 board, but it's just displayed in a linear fashion, which is actually how it's stored. Again, we'll come to that. And we've got various food dumps on this board here, 500 I don't know what, seeds of food or whatever ants eat. And then we have a nest set up at 2,4 here, and within that nest we have 5 ants. Now that's what simulation 1 does. It always places a nest here, and then it randomly puts some food elsewhere on the board. Now, I can display a particular area detail, so I can go from one position to another. So I'm going to start at position 1,5. So let's do display area details. Now I'm going to start at 1, 5, and I'm going to display to 3, 5. And there you can see it's just displayed a small part of the board. Okay. I think they're the wrong way round, but we'll come to that later on. Okay, I can inspect a particular cell, so I'm going to inspect this cell 2,4, and we can see a bit more detail because in this simulation we have some worker ants, we have a queen ant, and that's it. But I know that the wiki page allows you to set up other types of ants, or at least one type of ant, I think, which is a soldier ant, and the zigzag guide, I think there's a flying ant and a flying ant day on that. So let's have a look at 2, 4. So I'm going to inspect 2, 4, row 2, column 4, which is where the nest is. In there you can see that we've got one queen ant. It's alive, been alive 0 stages. That is that we haven't moved on the game by stages, or the simulation by stages. So a bit like if you would sort of consider like a game of chess or anything like that, you can move on in stages, or a tick, if you like, of the game. So all these ants have initially been set up. They've all been alive for 0 stages, and that's it. They're all carrying 0 food, and they're all at the nest, and that is their home nest. And each ant has its own individual number too. We've got ant 2, ant 3, ant 4, ant 5, and then ant 1 is the queen ant. So I'm going to advance one stage now, which is option 4. And I'm going to display the overall details. Now you can see that the ants have moved away from the nest. Okay, we've got a couple of ants up here, we've got an ant down there, and they've headed or tried to randomly go and seek out food. Within this grid, and that's what it is, a grid, there are, each item on the grid can hold an ant, it can hold food, it can hold pheromones, and it can hold food, ants, nests, and a pheromone. That's it. Okay, so I'm going to display now in detail 2, 4 and see exactly what's going on in there. So like inspect cell 2, 4, and we can see that there's only one ant. It's the queen, and it's been alive by 1 stage because we've moved it on. Okay, so let's have a look now at 1,3. There's 2 ants there. Okay, so let's inspect 1,3. Okay, so there's a couple of worker ants there. They've not got any food yet. Their home nest is 2,4, we know that, and they've been alive 1 stage. So I'm now going to actually move the game on more than 1 stage, which is option 5. So, how many stages to move it on by? I'm going to move it on 5 stages, so that moves it on 5 goes. So let's display the overall details again. Number 1. So there we go. Some pheromones have been dropped off on 1,5. The food has gone down, and there's an ant here. Presumably that's had some food, and there's got some food, and there's a couple of ants at the nest. So let's do an inspect cell of 2,4 again, and there you can see that there's the queen ant is still there. It's been alive 6 stages now, 1 + 5, and ant 3 has come back with some food, and it's also been alive 6 stages. Okay, so to get the detail, you have to inspect the individual cells. You don't get that level of detail if you display the overall details. Right, finally, you can quit the game. Okay, so we'll quit the game now, and I'll do a quick talk through the code. So let's quit the game. Right. Okay. So let's go to the top, and here we go. So this is where the program enters, of course, in the main. We've set up a public random value here. This enables us to get and generate random numbers using that. The Copilot comments have helpfully put these comments in here. So when the game is started, these are your 4 different simulations. So the user is the user is asked for a simulation here, okay, and then we get a console read line which basically puts the sim number in there. Now that's a string, which is why that doesn't crash if we put in hello at that particular point. That's not always the case, but here it won't crash. So we'll put if we've selected 1, then it does this. Now I'm going to try and explain some of the OOP terms as we go along here. If you're more procedural programming, you know, when you're just getting used to OOP, hopefully that will help. So here we've got a list that we've set up of the simulation parameters. So the simulation parameters are described here, and even though this is commented in and you won't see this on the day of the exam, you can still see it further down in the program, and I'll show you where that is. Okay, so here we're doing these are the 8 parameters, 0 to 7. Okay, so this 1 here is the starting number of nests. The 5 is the number of rows. That 5 is the number of columns. 500 is the starting food in a nest. Then we've got the number of food cells. So on that simulation there, you saw that there were 3 cells on the grid that were populated with the 500 items of food. Okay. The starting ants in a nest, well, there were 5 ants in that one nest. We saw that. And then we have this here, which is the new pheromone strength. So I don't know whether you know about ants. I'm not an expert, but they follow pheromone paths that are set up by other ants. So ant discovers food, it leaves like a trail of pheromones to lead other ants that ants like to help each other out, and other ants can then go and get the food as well and take it back to the nest. Now finally we have the 50 here, which is the pheromone decay. So every time there's a stage, it is moved on by 1 tick or 5 ticks as we did before, we lose the pheromone decays 50 out of those 1,000. Right, okay. Stage simulation 2 looks pretty much the same, except the pheromone decay rate is 100 there. Simulation 3, we've got a different board size, 10 by 10, and a decay rate of 25. And here we have 2 nests on simulation 4, and again we've got a 10 by 10 board. We have the starting ants in nest, which is 6. By the way, there was 9 ants start in simulation 3, and we have a decay rate of 25 on the pheromones. Okay, so that basically sets up the simulation parameters. Now this is the OOP part here. We have this class simulation here, and we've passed over that list. We've passed over one of these lists that we've set up. It is just one list, simulation parameters, but they've been set up in a different way depending on which option we have chosen. And that creates a new object, and it's basically this simulation. This simulation is the world in which ants live in. So we are essentially setting up a new world for ants to live in here called simulation, and within that we've planted we planted nests, food, not pheromones to start with, nest food ants into that world called this simulation. So this is the class, that is the, if you like, the blueprint. It doesn't exist until we create a new instance of it called this simulation. So that's an important definition. The class is a blueprint for an object, and this is the object. So try and get the terminology right for OOP. There could be a marker 2 in it for the exam in section C. Right, here we go. So we've got the choice. The user is displayed a menu of saying which simulation, which choice do you want to make. We've chosen the simulation, and this is where we make a choice on that menu that we saw before. Case 1, we're going to print the whole grid. Now, if you remember, this has just got one right line here, okay? But that right line produces many lines. That produces the whole board, if you like. And the reason is that this get details here, that method get details within this simulation, that basically sets up a string, and it returns a string for that right line to produce, and that string even includes new lines. Okay. Here, this is the bit, if you remember, where we just pick an area of the board that we want to produce, and so not display the whole board, but just maybe a subsection of it. So we have two start and end parameters for that. Okay. Case 3, we have this bit here where we inspect a single cell. This is where we get the detail, the number of ants present, the pheromones, the food, the nest, and all that kind of stuff. That was the detail one. Okay. And again, we get the cell details, and it right lines. It's just one right line, but it will have new lines in that right line. So it's like a whole thing that a whole subsection of the board that we print. Even though it looks like just one, it outputs one right line. It doesn't. Okay. Advanced stage. This calls up advanced stage one time because we're just advancing it one tick or stage within the simulation. And then here number 5 calls up exactly the same method called advanced stage, but this time instead of inputting 1, it's whatever the user has inputted here. Okay, and we inputted 5 in that little demo that I did before. Now, this is in a do. Let's just bring it up a little bit. This is just a do while, okay? And it just continually goes round there until we end the simulation by exiting with the value of 9. Unless 9 is chosen, that while do loop will run forever, okay? Constantly prompting you to put something in. Interestingly enough, all the ants die off. When I've run this simulation, I've run it a few times. I'm not very good at keeping the ants alive, or, well, I guess it's not up to me. There's nothing I do. But the events eventually die off, and you can continually keep playing this game and nothing changes, because the world is still there, but there's no ants living on it. Okay, so maybe one extension task is to end the game when all the ants die off. Who knows? Okay. This is the bit that displays the menu, so that is called there. This is typical the way AQA write these things, and probably any good programmer really, which is to break things down. We've got the display menu there. That just calls up this. Doesn't return anything, it's a static void. Okay. so it just prints the menu out. Okay, this is the way you get the choice, which is basically just a read line, which is that. So they could have actually done those right lines and the read line there, but it's been broken down into these two methods here. Okay, the rest of it are methods that are called up at various points. We've got a static void to get the cell reference here, which is asking the user for a cell reference. You saw us do that when we were running before. We were getting a row and a column for various things when we were doing, say, the inspect an individual cell, or whether we were going from one position on the board to another position of the board. Okay. Then we have the class simulation. Now, remember what I was saying? Class simulation is the blueprint for setting up an object. I've put this in here because you will see further down here we've got protected lists. So if you remember, public, now I think the random, for example, above was public. That can be accessed by anyone, anywhere. Private means if these were private, those lists would only be available within this particular class. Protected means it's available in this class or any class that inherits from it. And then internal is any class in the same project assembly. So if you can imagine the way this works, okay, private, public is anything, anywhere, anyone, anywhere. Private is only yourself, okay? And protected, this is a bit of an analogy, is like, you know, you will protect you and your children, basically any class that inherits it from it. So that's what protected means. So again, there's a few of these protected bits and a few public and a few private. Who knows, there might be a mark or two in section C asking you what protected means. Okay, it's a value, or you know, it's a list or a variable that can only be accessed by the class or any class that inherits from it. So do try and memorize or make sure that you're familiar with this OOP terminology. Now, here we go. So this is the simulation. The simulation parameters are passed over, remember, up here. Okay, by way of this list. There we go. That's passed over wherever we were. Okay. And that's passed over in a list. That list is then broken down into unique variables here, starting number of nests, number of rows, number of columns, etc. And those values are passed over to them. Then the grid is built up by, which is basically rows and columns. And we're adding a new cell to the grid for each row and column. So if it's a 5x5 board, there are 25 items added to that grid. Now, remember what I said, that grid is a list which is populated, and it is a single dimensional grid. So it looks like it isn't, doesn't it? It looks like we're actually in two dimensions here, but those items are added like in a linear fashion, 1 to 25. If you've got 5x5, if it's 10x10, then there's 100 items added to that grid. And further down, there is a method that calculates the right position by inputting the row and the column and returning something back, so which we'll see that later on. Then we set up a nest. Now, we're always going to set up at least one nest at 2, 4. Okay, at position 2, 4, we saw that in the demo that I gave before. So that's that. Now, if we're setting up 4 nests, which I think was simulation 1, I think, okay, then we're then going to go from 2 to the starting number of nests. If that was 4 or 5, I can't remember now, starting number of nests. Okay, so not from 1, because we've already set up 1 nest at that 1 position. Okay, so there's always 1 placed at that fixed position for reducibility. That's probably so that AQA can say, can see how your simulation is running and makes it easier to mark. Who knows? Okay, so the thing is, nests, you can only have 1 nest in 1 particular grid position. You can't have 2 nests in 2, 4. So we've got this little routine here which makes sure that we're only placing a nest where there isn't a nest already. So we pick a random place on the board and a random row on the board, and we pick a random column, and we set up this Boolean value allowed equal to true. So we're assuming that we can put a nest there, but we're then going to check it, and we're going to go through this list here, which is nests, and that is going to check every position within the nest, and we would get returned a row and a column from that nest, and then we just check that against our newly randomized positions here, and if the row is equal to a row we already have and the column is equal to the column that we already have for that nest, then we're going to set that to allowed equal to false, because that position already has a nest. We found it in this list here. So we're going to set that to false, and in which case that loop will go round again. That it's not allowed, which means so the false becomes a true, and that basically goes round the list again. Otherwise, we're going to call up this little method here called set up a nest at row column that we've just randomized. Okay, and then the for loop is going to continue for however many nests that we need to set up, bearing on this parameter that's been passed over. Now, exactly the same thing happens here for food cells. So we're not going to make it too easy for the ants. Okay, I'm not quite sure how this works, but we're not going to put the food where the nests are. We're going to put them randomly on the board, on the grid, but not where there is a nest. So again, exactly the same thing. Bool allowed, randomize a place to put, a row and a column to put the food, and then we are going to just check the nest positions to make sure that there isn't a nest where we're trying to put the food. If there is a nest, then we go back and randomize another position. Okay. Otherwise, we're going to call up this method here, which adds food to cell. Now, I don't know if this is a bug. It was something I've only just spotted, really. But here we've got hard-coded in 500, okay? So we're going to pass over 500 to the add food to cell. But yet, if you look back up here, those are parameters starting food in nests. So even if we set that to 1,000, I haven't tried this, but if we set that to 1,000, it's still not going to put 1,000 in there. It's going to put 500. Let's give that a whirl, actually. Okay. So let's go for simulation 1, where we have set that value to 1,000. And we're going to display the overall details, and yet the nests have only got 500 in them. So that value has not been passed across. It's been hard-coded. So that might be a bug for us to fix. Okay, so let's go back down there again. All right, So we're adding food to sell. It's been hard coded in there. We probably want to put in starting food in nest. In fact, I know it wasn't what I intended in this video, but let's just cut that down and put drat. What was it? Starting food in nest. There we go. So let's give that a whirl now. I think I've still left it at 500 because I was being good and putting it back to what it was. So let's go for 1,000. Run that. Enter simulation 1. Overall details. This time we have got 1,000. So we've kind of fixed that bug. I'll have to remember to put that back later, but let's move on. I don't want to keep you too long on the first video. Okay, so there's the food, and we've added the food to sell. This time it's not been hard coded. It's not 500. We've actually put the value that the program thinks it's passed over to it. Okay, set up nest. This basically adds to this list here, the nests list, where we've added to that list, and then here this is where we add ants. We of course we add one queen, and then we add a number of worker ants to there. So we might add 4 more workers. I think simulation does add 5 ants, so one of them is a queen, and then 4 workers are then added to that list ants. Okay. So far so good. This is where we add the food to a cell, and this is where we get the grid index, okay, and then we add a quantity of food using update food in cell and add food to cell. More detail. I think it would take me an hour or so to go through this video in so much detail, so I'm going to try and skim over some of this now, and we'll see more of it in future videos. Now, I said, if you remember at the beginning of the video, or somewhere near the beginning of the video, that the grid is stored as a one-dimensional array. Sorry, not an array, a list. Okay, grid is a list, and we add to it, and we pass over a row and a column to this get index, and that will basically subtract 1 from the row. So if it's row 2, then that would be 1 times the number of columns, so it would be 5, say, if it was a 5 by 5 board, and then we add the column, which say that was 3 minus 1. So it basically comes up with a calculation to put this on a flat one-dimensional list based on the rows and columns, and that's the calculation where it does it here, and it returns that value. So this is how it's giving the appearance of a two-dimensional array, but using a two-dimensional list or array, and we are actually putting it into a one-dimensional list. Okay. There are some more methods here. Okay, private one here. It's a get index of neighbors. So this basically goes around the 8 neighbors. So if you've got an X, if you've got an ant in one of in the middle one, you can imagine it goes round and looks at the 8 neighbors that it has in the adjoining grid cells. Okay, and this is how it does it. It just basically goes around the rows and around the columns. Does a little bit of an algorithm to do that. If it's out of bounds, we just encode that as a -1, and then we return the list of neighbours. So you can imagine that if the ant is on the edge of the board, it may only have 5 neighbours, I guess. Right. Scan neighbour cells and return. So this is get index of neighbours with the strongest pheromones. So if you remember, we have the bit where the ants follow pheromones around, hopefully clues left by other ants that sort of say where the food is, and it looks around again, around the neighbouring cells to see if there's pheromones in there. Okay, and it'll give an index of the strongest pheromone as a return value. The nest, this is get nest in cell. Okay, so this returns whatever the nest is within a particular cell. That looks like it just returns null, actually. Oh yeah, so it does return something, and you know, if there's yeah, so it does return it quits at this particular point if there is a nest. Okay, if the ant already has a pheromone in this cell, top it up. Okay, so if the ant has already been past that particular cell, then it just basically tops up the pheromone level in that cell, because the pheromone levels decay. So it needs to keep topping them up each time it goes past. Okay, so we're adding to the list pheromones here and putting the pheromone, the new strength, and setting up the pheromone decay, etc. Number of ants in a cell, get the number of ants in a cell, so this counts the number of ants that are within a location on the board and returns it. Get number of pheromones in a cell, same principle, but it goes through the pheromones list. Get the strongest pheromone in a cell, so there might be a number of pheromones that have been left in a particular cell. Here we are returning the strongest. Okay. Get details. So if you remember, this is worth looking at a little bit more detail. If you remember the get details, when the board is displayed, as it frequently is, it's just one right line. This is where the several lines of the board are collated, including a new line which is added to the string details. So you've got the string details here, which has been set up with a null value, and then it's populated with the rows, the columns, the detail. So you've got the string nest here, the string ants, number of ants, the pheromones, number of pheromones, and the amount of food, and that's all added as a string to these details, and then at the end a new line. So if I run this code again now, enter simulation1, if I display the overall details, then that is all contained in one string called detail, and it's outputted like that, and it is exactly the it's exactly this function here called get details that does it. Okay, get area details, that was for a subsection of the board. Quickly look at that. So get area details, so we will go from 2,4 to, oh, that would crash the program. Okay, to 4, 4, and then it gives you a subsection of the board. Okay, so that's basically what this displayed. Same principle. We've got details here set up as a null string, and then it's added to, including the new lines, and then eventually there's a right line back in the main section of the program, I think, that just right lines that detail. Okay. Add food to nest. Okay, so this is going through the nest and adding food to it depending on what values have been passed over. Again, skimming over this. Okay, get cell details. Now this again is a string with details that have been set up here. Current cell details, get details, and then we are going to start adding all of this stuff to the string, okay, and outputting and returning the details. This was the ants in details. So again, just from the program, simulation1, and inspect cell, we're going to inspect where there's always a nest, and that's what that outputs, okay. Again, it's all done by creating the string details and then building up that string and then returning it. This is the advanced stage. So remember that the program runs by stages, a tick count. This is the bit that does it. Okay, so we've got this this public void advanced stage. You pass in the number of stages, either one or several, you know, or 5 or whatever it is, and this basically decays the pheromones. It moves the ants about, okay, and gets them to drop food and lay pheromones, and then it does the same for the nests as well, okay. So nests, food is consumed, ants will die off, or new ants will be born within the nest. So here we've got the first bit, which is the pheromone decay. Okay, there. So it goes through all the pheromones that are on the board, and it will calls the pheromone advanced stage. So actually, we'll come to that in a bit. The advanced stage that's called up there is the pheromone advanced stage. So we will look at the pheromone class. We'll see that there, and then we've got the pheromones to delete. That's another method there. Okay, which basically marks for deletion. And we remove here pheromones. Yeah, so we've got this list, pheromones to delete. We go through that list and then we remove the pheromones from that list. Okay. For the ants, we've got an advanced stage here, which is called up for the advanced stage bit, and 3 parameters are passed over: nests, ants, and pheromones, and we move the ants on. So this is basically getting the ants to move about. If the ants are carrying food, as in it's greater than 0, and it's at its own nest, then we want to drop off that food and empty, we deliver the food to the nest and empty the ant. So the ant drops the food off and then goes off out looking for more food to bring back, empty-handed. Obviously it's sent on a mission. Otherwise, we are checking to see if the amount of food is still greater than 0, and that the food, the current amount is yes. So the current cell, does it have any food in it? Yes, it does. And the ant has 0 food. Then we are going to, and the food capacity is greater than 0. Then the ant is going to basically means if the food cell, if there's food in the cell and the ant's not carrying anything and it's able to carry something, try to pick up some food. It's not always successful on this. This is based on this random value here, which is, if we don't get a good random value, then we keep going round that while loop, and we update the food carried. So the ant tries to pick up food several times. Okay, there might be, the co-pilot's come up with this suggestion here that we might want to avoid looping by just getting it right first time, by randomizing, by changing the code there, not looping round and just getting it right. Otherwise, we're moving about and pheromone laying. So if the food is carrying, then we need to update the pheromone in the cell so that we can reinforce the trail back to the nest or wherever it's going. I think it should be going back to the nest if it's got food. So next, choose the cell to follow. This is where it moves about. So we're checking the neighbours. We're checking to see if those neighbours have got pheromones in them and coming back with the strongest one. If the strongest one is basically the best one to follow. Okay. So if homing movement when carrying food, it modifies the row and column directly. Okay. So here we go. Clamp movement. This is a possible update. Clamp movement to grid bounds after any direct row or column changes, especially if worker is homing, so it's heading back to the nest. In the skeleton code, movement is generally safe because neighbour indexes are validated, so there's some validation that goes on there. And then finally, we are calling the advanced stage, which is the nest version of the advanced stage, and passing over those parameters. So there are several advanced stages there depending on which object we are running it against. Okay. Now, here's some OOP terms. We've got a parent class here called entity. Okay, this is the overall class. It doesn't inherit from anything. It's a class on its own. And here we have get row, get column, get ID. Within here we've got advanced stage. Now that is virtual. That means it's overridable, which is just as well because there's nothing in there at the moment at the entity stage. Okay, and get details is the same. Get details will just return a null string at this particular point, but it's overridable. That means that within other parts of the code that inherits from entity, then there will be probably a new advanced stage and a new get details. So here's the first one. Cell inherits from entity. So it gets all those variables and it gets all those methods. Okay. We've got that protected value again, amount of food. And we have here an override. So that means that within cell, when we do get details, get details, it's going to run this one, not the one above. So this one returns a value, and then that's it. I think there's another one, update food in cell here. That's just a public void, not overridable. Now here we have an ant which also inherits from entity. Okay, that's what the column entity means, and within there we have the we have these protected variables here. Okay, we have the public ant, which is available throughout, and then we have the virtual int. That means it's overridable further down if we need to. I think there's a queen ant and a worker ant. Okay, so these are virtual methods. They're overridable. Here we've got the ant, which is the ant version of the static, of advanced stage, which means it's overridden the previous version of the advanced stage when we call it as an ant. And the same with the get details. That is overriding a previous version. So that's the one it calls. That's all it means. Okay. This is update the food carried. Change cell. Basically moving about. choose a random neighbour. So if there wasn't a pheromone in the next door cell, then we need to just choose a random one, and this is what does that. Strategy hook, workers override movement logic here. Choose cell to move to. Again, that's overridable. Overridable food carried. Overridable nets. Get nest row. Overridable get nest column. Overridable get type of ant. Okay, so we'll be looking at the worker ant further down, but worker ant is going to override pretty much all of them. Here we've got the queen ant. The queen ant doesn't override anything there at all. Okay, it's just got its own little, its own method that's been added to it here. Okay. Sorry, yeah, it's got its own variable of queen there. Okay, so here we have worker ant, setup type of ant of worker. Food capacity is 30. That's the maximum food it can carry. Again, that looks like it's hard coded in. Whether we want to make that as an option further down, who knows? We're overriding the get details. We're overriding the choose cell to move to, because we're going to try and move about based on pheromones and based on random values if there isn't a pheromone knocking about. Next we have this class nest, which is inheriting from entity again, and we have the nest where we've set up these values here. We have the change food, where we're going to change the food level within that, to get the food level. And here we've got an advanced stage within the nest. Okay, so this is overriding the previous advanced stage with its own version of advanced stage, and here it's updating the ants, changing the food. Maybe it's going to cull some of the ants if the food is low. It's going to randomly move ants located in this nest title. Okay, queens can be culled. This may stop future births. We might want to stop queens being culled as part of this. You know, worker ants are probably expected to sacrifice themselves before the queen goes. Okay. Birth logic, the queen has a 50% chance at reproduction, so this is where the queen reproduces. We have a 50% chance here, somewhere within that logic. Pheromone marks, so here we go. Pheromone marks left by ants, strength decays at each stage. So we have a pheromone class, again inheriting from entity. We've got the strength, pheromone decay, and belongs to, and we have these overriding, so we're overriding the advanced stage here with its own version of advanced stage, which has only got this little bit in, a lot less complicated than some of the other advanced stages in some of the other classes. Update the strength, get belongs to, turns the value belongs to, and then that's it. That's the code. Okay, I think I've just done that in just under an hour. I've probably skimmed over some of it, but hopefully you get the idea within less than an hour of how the program runs and where to find stuff within there. Again, I will hopefully do some further videos where we'll make some changes to this code. And you may want to just double check your OOP terminology, protected, private, public, override, encapsulation, which is where we make sure that only values can be changed through getters and setters, that type of thing. More of that hopefully later in some of the other examples. I have done a quiz on this, an online quiz on Wayground. I'll try and put a link to that in the comments for this video. Until then, this is goodbye for now, and hopefully see you in a future video. Bye bye.